In this video, we're going to talk about the square root function. A square root function is just the inverse of the parent function f of x equals x squared. And so let's take a look at kind of what we talked about in the last video of the inverse function. All right, an inverse function just takes the inverse operation of the original parent function. So let's go ahead and find the inverse function and what this square root function is going to look like. Okay, if we know it's the inverse of this square root or this square function, then we can find by using the inverse operation. So let's go ahead and do that right now. I'm going to switch the f of x to the y, and then I'm going to switch my x and my y. If you watched the inverse function video, you'll see why we do that. Okay, and then from here, what we're going to do is solve for y. So if we solve for y, we know that the opposite of squaring something is square rooting. So we're going to take the square root of both sides. And so what we get here is y equals the square root of x. And if we rewrite this using more mathematical notation, we can use f, or f inverse of x, equals the square root of x. All right, so this is going to be what our inverse function, or the square root function, is going to look like. And so let's take a look now at what this looks like graphically. Okay, as always, I'm going to start with the parent function, x squared. So we're looking at the left-hand side. All right, I'm just going to plug in some values. I'm going to do -3, -2, -1, 0, 1, 2, and 3, just to get a good set of values so you can see what that looks like. Okay, we're really just squaring all of our input values, so it should be pretty quick and straightforward. We do -3 squared. -3 times -3 is 9. All right, and we can do that all the way down. We get 4, 1, 0, 1. And so you'll see that'll kind of repeat the values now. So we have 4 and 9 here. Okay. All right, I'm going to graph these points as ordered pairs. So we have -3, 9. 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. -2, 4. -1, 1, 0, 0. And then now it's just going to reflect over that y-axis, so it's very symmetrical. And then everything else is pretty predictable right here. Okay. Let's draw this graph. I've graphed better, but that's okay for now. And then what we see is the red graph, okay, the square root of x. So the square root of x, now let's just choose some values. Let's choose some values pretty strategically here. Let's just choose the same values, but in this case, let's choose our output values, and you'll see why. Okay, so we're going to do square root of, or we'll do 9, 4, 1, 0. Now you'll notice they repeat, so we don't have to write them again. All right, this is going to be an important point I'm about to make. All right, so let's do this. We have 9, and if we plug this into our function where we do the square root of 9, well, I'm going to do some scratch work right here. The square root of 9 can be one of two things, right? It can be both 3 and -3, so it can be plus or minus 3. So if it's plus or minus 3, well, let's go ahead and include that. Let's make two separate values here. So we have plus or minus 3. So we have 3 and -3. And then we have 4. Well, that can be plus or minus 2. So there's two values there. Same thing here. We have plus or minus 1. Square root of 0 is just 0, right? There's no plus or minus 0. 0 is just 0. Okay. So now we have kind of we got some weird things going on here. So if I go right 9, let's go right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, it looks like we have a problem now, right? This is why we have some kind of weird things happen if we don't do something. So we have 9 as our input, but we don't know if we should use 3 or -3. Okay, so if we don't know, then right now it's not a function. So the inverse, in order for the inverse to be a function, we have to restrict the range. So in this case, we're going to restrict the set of possible output values to y is greater than 0. So in this case, we're just going to take all of our positive output values. All right, and you could take the negative values, but in this case, we're just going to take the positive values. Okay, so actually, and here's why. Because eventually, if we were to graph both of these points, it would look like this. But if we think about when we learned about the vertical line test, right there, well, that does not pass the vertical line test, so it's not a function. So what we have to do, again, like I said, is to restrict the output values to a certain, so to y is greater than or equal to 0, to our positive values. So let's go ahead and just worry about those positive values here. So we go right 9 and then up 3. So I'm just using these. So right 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, and then up 3, up 3. Then I go 4, 2, 1, 2, 3, 4, up 2. Right 1, 1, 0, 0. Okay, and again, we said that these negative values don't really matter. Okay, so we don't want to use those right now. So let's go ahead and draw that, and there we go. So you'll see, like what I mentioned earlier, you might want to include that bottom half, but if you include that bottom half, then it's not going to be a function anymore because it doesn't pass the vertical line test. So we'll ignore that. So we'll just look at that top half. Now, if you think back to that inverse functions video, what we did was drew that the diagonal line that goes down the middle. And so when you find that inverse function, it should be reflected over that line, y equals x. Remember, y equals x is our key line here. Okay, so the red line is the graph of the square root function, which is just simply an inverse of this function right here. Okay, so here's why, right? I'll kind of go in now to the math behind why you have to restrict the function. Okay, so by definition, each input of a function can only have exactly one output. So let's take a look here. If I decided to plug in 9, and the function is square root of x. So if I decided to plug in 9, well, we know that the square root of 9 is 3, but you can also do negative 3 times negative 3 to equal 9. So we can also get an output of negative 3. Well, if you're trying to decide which output to use, which y value to use, then you couldn't do that. You could not say, okay, I'm definitely going to use positive 3. Well, why not use negative 3? Okay, so you have to just kind of set that rule for yourself. Well, I'm not going to use negative 3 because I just told myself I'm not going to use negative 3. Okay, so you have to restrict the output values. You have to restrict your range. Now, that's kind of conceptually what's happening behind the scenes of square root functions. And in the next video, we're going to talk about how to graph using transformations. Okay, we're going to talk about how to graph using transformations in that next video.